All right, guys, it's the moment you all been waiting for. This is the last lesson of the year in calculus. All right, 5.7, we're doing inverse trig integration. Okay, so last 5.6, we did the derivatives of all inverse trig. All right, and you notice I have here a split screen of our formula sheet. All right, because we're going to be using a lot of it during the lesson today. So instead of clicking back and forth, we just have it there. As you're doing these problems, I would, anything that's going to come up on your last quiz, I would have this out and handy to be able to reference it because you'll be doing that a lot. All right. So those are the derivatives we did. We have three more things right here. And this is the integrals. Okay. All of this nonsense is going to be equal to arc sine. All of this is going to be arc tan. All of this is going to be arc secant. Okay. Now, how are we going to do this? All right. So, this type is a little bit different than what we've been doing. All right. This is actually, let me make this a little bit smaller so I can see this. There we go. All right. One thing that's different about this, we don't just have like a u and a du. We have this a squared, u squared, a squared, u squared, a squared, u squared, and a u. All right. So instead of just picking a u and a du, we're going to have to use a u squared and an a squared. That's going to help us out. Now, the key is, well, how do I know that I'm going to use this type of problem, integral, when I'm looking at my examples I'm going to do? All right. And that's the difficult part, is figuring out which method you're going to use. All right. Now, if I just gave you this problem, most of you probably be like, okay, well, maybe I can make it 4 minus x squared, right? Well, if I take u as 4 minus x squared, I make it du would be 2x. Well, I can't add an x. I couldn't do it that way. Okay. So my little hint to you would be, is if you have a dx on the top, no variable, just a dx, and on the bottom in the denominator, you have either a square root or you have something squared on the bottom and another number there, it very well is probably one of these things. And after you do a few examples, you start to see and pick up on some patterns here. Okay, so if you were to look at dx over the square root of 4 minus x squared, what of these, what form does this most represent here? Well, it's not this one because it doesn't have a square root, so it's either the arc sine one or the arc secant one. And there's nothing on the outside. We have, I think it looks like this one. All right. So what I'm going to do is, see how it's a squared and u squared? I'm going to select an a squared and I'm going to select a u squared. Okay. So looking at this, what is my a squared? Well, what's the number that's right here? A squared is 4. Minus, what's my u squared? My u squared is x squared. Okay. Now, what's going to happen is your a squared is going to be the one that has the constant. Your u squared is going to be the one that has the variable. All right. That's the way it's going to work out most of the time. All right. Got to keep that there. All right. So once you pick your a squared or u squared, I'm now going to find a and u. Well, if a squared is 4, what's a? We'll just take the square root of 4, which is 2. If u squared is x squared, what's u? Well, that's going to be x. And then my last step is I need to find my du, just like you did before. And the derivative of u, the derivative of x, is this 1, so that's just going to be dx. Okay. Now, what I'm going to do is I'm going to rewrite my integral using u squares, a squares, and du, so it looks like this. Now, remember, I need du is up top here. All of that needs to be my integral. Well, it already is. It's right here, right? I can substitute in my du, my dx is equal to du. So I put a du over the square root of, well, what's 4? Isn't that just my a squared? So I've now a squared minus u squared, because that's what x squared is. That's my u squared. So I have this, I can rewrite as that. And my formula says whenever I have du over the square root of a squared minus u squared, and I could scroll up because what I can do is I can just look on the formula sheet and it is, notice it is right over here. All right, that's this one right here. All right, it is equal to sine inverse sine of u. Well, what's u? U's right there. U is x over a, which is 2, plus c. And there is my answer. Inverse sine of x over 2 plus c. That's what goes right there. All right. You're probably thinking right now, what did you just do, Mr. Geller? Well, the more you watch of this, I think you'll start to pick up. Okay. So, all right, as I look over here, what I want you to do, this next one. All right, same thing. If I made this bottom and thinking, oh, this could be du over u. Well, if I make the bottom 2 plus 9x squared, I get 18x. That's not, there's no x up here. So whenever you see an x squared on the bottom and you don't see an x on top, you see a dx, it's going to be one of these three. Which one does this look like? Well, it doesn't look like the inverse tan because there's no square root. All right, so let's do the same thing we just did. Let's pick an a squared. We pick our u squared. The a squared is going to be my 2. The u squared is 9x squared. Once you have your u squared and your a squared, you take the square root of each of these. The square root of 2, the square root of 2 is the square root of 2. U squared is 9x squared, which means u is 3x. I find the derivative, I find du, which is 3 dx. Okay, now I rewrite everything just like we have in the past. I need all of du here. I have to add a 3, which means I put a 1/3 on the outside, which means this right here is my du over a squared plus u squared. Right? And now I just rewrite that answer. So it's 1 over a, which is the square root of 2. Don't worry about rationalizing. Keep it that way. Oh, forgot to do a third. So 1/3 times 1/2 inverse tan of u over a, which is 3x over the square root of 2 plus c. It's an awful handwriting, sorry. All right, and there's your answer. All right, so really it's 1 over 3 root 2 inverse tan of 3x over the square root of 2 plus c. All right. All right, let's scroll over here. Now, of these three, when you see a square root with some squares in it, and then you see this variable on the outside, that's screaming to use this bottom one right here. All right, so I'm going to use a squared is going to be my, it's my u squared is, a squared is going to be what it's by, it's the constant. So it's being subtracted by it, so that's 9. Whoops, that's a huge 9, sorry. U squared is your 4x squared. Okay. A is then 3. U is 2x, which means du is 2 dx. Okay. All right. Now, got to be careful about, we need to make it look like this, right? So I need du on top, which means I need to add a 2 up there. Let me just change colors to see I'm adding. I'm going to add a 2, which is okay, which means I'm going to put a half on the outside. So that's du. I need u on the outside. Well, I need to have 2x, not just, so I need to add a 2 on the bottom, which means that means I've multiplied the reciprocal of that. So these cancel each other out. So I don't need to put anything on the outside. They cancel each other out there. So I have du over u square root of u squared minus a squared, which equals, now you just go and 1 over a, 1 over, what was a? 3, secant to the negative first, so the inverse secant of u over a, which is 2x over 3 plus c. And there is my answer. All right, so here's an example where you had to use inverse sine, inverse tan, and inverse secant. All right. Now, if we look at 4, notice the difference between 4 and the first 3. This one has an x up top. This still has an x squared plus 4. You might be like, oh, we can use inverse tan, but here's the difference. There's an x. If there's an x, do it old school. Just pick a u. Make u the denominator. X squared plus 4 du would then be 2x dx. right? We make sure that all of du is here, so is that. So we added a 2, which means 1/2 goes on the outside. The integral, well, what's 2x dx? That's my du over x squared plus 4 is my u. Well, what's the integral of du over u? Well, it's right here. If you look, it's natural log. So 1/2 natural log of u, which in this case is x squared plus 4 plus c. And there you go. All right. So even though it looks like similar to number 2, the difference is dx was there and there's an x here. So if there's just a dx on top and you have like a square on the bottom, it's probably one of these 3 new things. If not, do it how you have done it up to this point. All right. So if you see 5, we got a square root, we got an x squared. It's just a dx. So since we're doing 9 minus and there's nothing on the outside, it's probably going to be like number 1. All right. So I'm going to pick u squared and a squared. Notice I put u squared first, a squared second here. It doesn't make a difference. U squared is the one with the variable. A squared is the constant. U would then be x, which means du is just dx. All right. A would be 3. All right. So dx, that's all there. So I don't need to add anything. That's just my du. I don't have to put anything on the outside. And then it's the square root of 9, which is just my a squared minus x squared, which is my u squared. So that's right here. All right. This guy right here. Right. Sine, inverse sine. So you just need to copy it down. Sine, inverse -1 of u, which is x, over a, which is 3, plus c. And there is your answer. All right. Now 6. Notice 6 has an x. Have an x squared. So it looks like it could be like number 5, but it has an x there. So just pick u as whatever is underneath. So old school, 4 minus x squared. The derivative of 4 minus x squared is -2x dx. I add a -2 there, which means I put a -1/2. And I get du over square root of u, which is u to the 1/2, which means I have -1/2 integral of u to the -1/2. Just do basic integration. So that's what? -1/2 u to the 1/2. And then I take the reciprocal of that, which means I put a 2 here and a 1 here. They all cancel. And I'm left with an answer of -u to the 1/2 plus c, which is -4 minus x squared. Now you could just put the square root, but I'm not going to. I'm just going to put plus c. And there is your answer. Okay, so you see some examples where you had to use a squared and u squared, and then other times just became u and du. All right. Now look at a few more of these. We're not going to do all of them. Okay. I'm not sure why it skipped from 6, 7, 9, 10. You know, that's how it goes. All right. So what I want to do here is notice there's just a dx here. If there's just a dx and you have a square at the bottom, it's probably one of these 3. This one is just a dx with the square at the bottom. It's one of these 3. Hopefully you can tell which one, either the sine, inverse tan, or inverse secant, you should be using for those. All right. Now for 7, this one's going to be the tangent. All right. That's going to be inverse tan. So you're going to make a u squared. You're going to make an a squared. Your u squared is x squared. Your a squared is 16. Your u is x. Your du is dx. Because the derivative of x is just 1. Your a is 4. You don't need to add anything. So this just becomes the integral of du over a squared plus u squared, which is this formula right here. And the answer is 1 over a. Well, what's a? 4. Inverse tan of u over a, which is x over 4 plus C. And there's your answer. All right. Once you know which one to pick, these actually are pretty easy. Okay. Now, number 9, we have our dx. Which one of this look like? Well, we got this thing on the outside here. So that u, that's going to be this one. So we still do the u squared, which is going to be our 9x squared, and our a squared, which is 4, which means our a is 2. We're just taking the square root, which means our u is 3x. Our du is 3dx. Okay. Now, notice this 2, this u, I don't need that. So I'm going to move that to the outside, which means I'm going to have a half on the outside. Now, in order for me to have du, I need to add a 3 here, which means I need to put a 1/3 on the outside. So that's going to be du up top. Now, if I move that, I need x. I need to add a 3 there, which means I need to put the reciprocal 1/3 is actually 3. So these actually cancel. So the only thing we have to worry about is the 1/2. So the 1/2 integral, because we just moved this 2 to the outside, and add a 3 on the top, 3 on the bottom, which means they canceled out. So it's u square root of u squared minus a squared, all right, which is 1/2. Now I just do this, which 1/2 times 1 over a, which is 2, inverse secant of u, which is 3x, over a, which is 2, plus c. So 1/4, because 1/2 times 1/2 is 1/4, inverse secant 3x over 2 plus c. All right. Now, 10 and 11. All right. 10 and 11 look very, very similar to each other. Okay. And I will tell you right now, on your last quiz of the year, there'll be one just like 10 and just like 11. And one of them is going to be done using this, and one of them is going to end up being du over u. Okay. So, if I were to do this one, right? If I were to let's try this as u squared and a squared, because it could be like the tangent, right? Because my u squared is what has x. If I made that e to the 6x, right? And I made my a squared 4, which means my a is equal to 2. My u, well, what's the square root of e to the 6x? Well, when you take the square root of something with a variable, you just divide what's x squared? It's x. What's the square root of x at 4th? It's x squared. You take the exponent and divide it by 2. So 6x divided by 2 is e to the 3x. All right. And how do I find the derivative of e to the 3x? Well, I look at my formula sheet. E to the u is e to the u du, which is e to the 3x, rewrite it, times the derivative of the exponent, which is 3. And I'll throw a dx. Notice, what do I have up top? I have e to the x3, e to the 3x dx. I just need to add a 3, which means I put a 1/3. And there's my du over, what's 4? 4 was my a squared. E to the 6x was my u squared. And I have this right here. So that becomes 1/3 times 1 over a, which is 2, inverse tan of u, which is e to the 3x, over a, which is 2, plus c. So the answer would be 1/6 inverse tan of e to the 3x over 2 plus c. It would be all of that. All right, so now 11, e to the 3x over 4 plus e to the 3x. So the difference, I don't know if you guys notice this, is the difference is in 10 that this one is half of that, like the square root of this, okay? These, they're equal. The one they're equal, we are not going to do u squared and a squared. The one where the exponent is half of this, that's where you're going to use u squared and a squared like we did here. So what we're going to do for this one, this is just going to be u and du. So we're going to make u the denominator, which is 4 plus e to the 3x du. Well, what's the derivative of e to the 3x? We just did that up there. It's e to the u du. So it's e to the 3x times 3 dx, which we just add the 3 there, 1/3, integral That's all du over u. So this one turns into a nice easy du over u. In case you forget what du over u is, it's right here. Natural log of u plus c. So it's 1/3 natural log of u, which in this case is 4 plus e to the 3x. Whoops, I don't know, I wrote dx, plus c. All right, and there's your answer. Okay, so there will definitely be one with a number plus e to something. The one that are the same, it's u and du. If it's like the one that is not, the exponents are the same, where it's half, that's going to be the u squared and a squared one. Okay. All right. Now, might as well just do these last two together with you. All right, difference with 12. Notice there's no just dx in here. This one is dx. This one's going to be u squared, a squared. This one is not. All right, this is just going to be a u is 16 minus x to the 6. Du is negative 6x to the 5th dx. I'm going to add in my negative 6 there. So I have negative 1/6 integral. Right there is my du over u to the 1/2. So this is very similar to one we had on the front side. It just becomes negative 1/6, the integral of u to the negative 1/2, and we just do some basic integration with this. And it's negative 1/6. We add 1 to the exponent, it becomes 1/2. Then put it over 1/2, which is the same thing as the reciprocal of this. So it's 1 over 2. Cancel out, that becomes a 3. So my final answer is negative 1. Well, I don't want to do that color. It's the same color as that. Negative 1/3 u to the 1/2, which is 16 minus x to the 6th to the 1/2 plus c. And there is our answer. Okay, so if you don't see a dx up there, except for this example, the one we did in number 10, it's going to be a u and du. See, here's our dx, number outside, so that's going to look like this guy here. So that's what we're going to make it look like. So u squared is going to be our 16x squared. Our a squared is going to be 1. Our u is then going to be 4x. Our a is going to be 1 because the square root of 1 is 1. The derivative of 4x is 4 dx. Change this color. So I need to have a du up top. I have dx. I need to have 4 dx to make that so I'm going to put 1/4 on the outside. All right. And I'm going to take the integral. And that becomes du. Over, I need to have u. Well, u is 4x. That's there. Good. I don't need to add anything. So I'm good. Square root of u squared minus a squared. Now I just write my final answer. I just look right there, follow the directions. So 1 over a, so it's going to be 1/4 times 1 over a, which is 1 over a is 1. So it's just going to be 1/4 secant inverse of that, u, which is 4x, over a, which once again is 1, so I don't have to write that, plus c. All right, and there is my final answer. All right, so we are now officially done any new material for the year. All right, I'm going to give you another worksheet to practice. Next week, we will be doing a review sheet that's going to look identical to the quiz. It's going to be made up of half of it is going to be derivatives, half of it is going to be integrals. All right, and it's going to be all the different types of methods that we've talked about over the course of the year. Okay, and once if you can understand the review, you're going to do great on the quiz. And we'll go over all that next week, and you'll take your final quiz on Friday, June 5th. If you guys have any questions, please let me know. This will take some practice, right? So I'm not making you submit this assignment. You don't have to submit this stuff to me, but I highly, highly recommend you have to practice it. All right. You have to practice it. All right. If you have any questions, like I said, let me know. Otherwise, I will talk to you guys soon.